Welcome back, students. This is Module 2.4.7, the greenhouse effect, global warming. You will recall previously we talked about the global carbon cycle and the fact that humans had impacted that with the potential to cause something called human-caused global warming because of the greenhouse effect. So let's learn what the greenhouse effect is. The greenhouse effect is a phenomenon in which high energy shortwave solar radiation shines down upon the Earth, passes through the atmosphere because it has its high energy short wavelength, very powerful. Some of this radiation certainly is still reflected by the Earth in the atmosphere, but much of it reaches the Earth where it is absorbed by the Earth's surface and it warms the Earth's surface. And then some of this energy is re-radiated. It is emitted as low energy, long wavelength infrared radiation, and it goes up into the atmosphere. And as it does, it encounters the atmosphere. Some of the infrared radiation will pass through the atmosphere, and some is absorbed and re-radiated in all different directions by greenhouse gas molecules. The higher the concentration of greenhouse gas molecules in the atmosphere, the more of this infrared or heat that is absorbed. And this causes the Earth and the lower atmosphere to warm. And that, in a nutshell, is how the greenhouse effect works. And no one really says that it doesn't work. So as we get higher concentrations of water vapor or greenhouse gases such as carbon dioxide and methane in the atmosphere, then we have greater warming of the lower atmosphere and of the Earth. And remember, if we look at the history of humans in the past 100, 150 years, we have really developed greatly our society based upon the exploitation and the use of fossil fuels. And this has released a tremendous amount of carbon dioxide. And that's just kind of anecdotally looking back at the history of humans. That is not really scientific evidence, but it's worth thinking about. This, in fact, this graph shows three different lines. One line is the dotted blue line here, and that corresponds to carbon dioxide levels. And notice it goes back thousands of years, and we have been measuring carbon dioxide levels directly since about 1950 in Hawaii, one of the places on the planet that has some of the cleanest air. And so previous to that, this graph is based upon numbers from bubbles of air trapped in ice, frozen, usually from Antarctica. Notice the other two lines that we have there. We have measured temperatures, which is the red line, and it only starts in the first third or so of the 1800s. And previous to that, this is temperature reconstruction, this orange line that goes back thousands of years. But we can definitely see that there has been an increase in both carbon dioxide levels as well as in average global temperatures. And there is a correlation here. And scientists who work in this area have hypothesized that if we extrapolate the data and the trend with carbon dioxide continuing to increase, that the temperature could go up tremendously. But if you just don't even look above the green part of the graph, this bottom portion of the graph here, you can see that there's a lot of noise in this data, that it looks like the teeth of a shark. And when we say there's noise in data, it's hard to definitively say that this is a trend. And this is one of the reasons that for many, many decades, scientists were uncertain about what was going on. Some of these big dips here, some people are very critical of science for hypothesizing, well, if this dip continues, if this trend continues, we're going to have another ice age. And in fact, we had just come out of a series of ice ages and warmings. And so it may or may not be something that we want to hypothesized, but certainly people have seized upon that as being some major issue. But we're confident that carbon dioxide levels are going up, and that this is one very good possibility. In fact, the most accomplished scientists in the world, including the American Academy of Science and the British Royal Academy, they all have position papers that say that human-caused global warming is a real phenomenon. Because teasing apart, I said earlier we had ice ages and other things. Teasing apart from the background noise can be difficult, but as I say, the most prestigious scientists in the world have concluded that this is a genuine phenomenon. And there's certainly a lot of political stuff that goes on, a lot of naysayers who, for various reasons, people that often work for fossil fuel companies, don't want to believe this. Anyway, notice that we're just talking about the change in average temperature. A change of just a few degrees is what we're talking about over the next years. But this is a change in the average temperature. And that's one of the things that people need to realize. There's really two parts that you have to understand to really understand why people are concerned about this. One is that the range of change doesn't exceed extremes of the past in the history of the Earth. It's been very hot and it's been very cold, and for various reasons on the planet. But what is happening here that seems somewhat unprecedented is the rapidity of the change, the rate of the change, not the magnitude, but how fast it's changing. This doesn't leave time for life to adapt. Less than 2 degrees Fahrenheit in a century would be faster than any change in the last 10,000 years. And we're talking about changes at least that fast. And the second thing that you have to understand, not beyond the rate of change, is that we're not talking about normal daily or seasonal fluctuations, but we're talking about change in the average temperature. We all know in Arizona in one day, the difference between the high and the low temperature can be 30 or 40 degrees easily. And so if we're talking about a change of 3 degrees, people scratch their heads and go, what's the big deal? It's a change in the average, and that's a huge difference. And remember, if the change occurs quickly, that won't allow enough time for natural populations of plants and animals to migrate or to adapt by the evolutionary process. And if it changes very rapidly, it will be a major disaster for many biological species, for many species. Some of the possible consequences of rapid change. I'm just going to throw out some of this stuff rather quickly. Glaciers could melt. We could expand the ranges of some plants and animal species that are adapted to warmer climates, but it could then cause the extinction of other species. For example, here in Arizona, up on the San Francisco Peaks, north of Flagstaff, the highest point in the state, we had a little patch of vegetation called alpine tundra, and it's crept up to the very top of the highest peaks, and as the climate warms, it has nowhere to go and it will become extinct. The ecosystems that are most threatened are coral reefs, whose little keystone organisms, the corals themselves, are threatened by warming sea temperatures. It has to do with changes in pH because they have calcium carbonate exoskeletons, and if the ocean becomes more acidic, they won't be able to form corals. Polar seas, where ice formation has been critical to the ecosystems there. Think of the poor polar bear. We'll talk about that later. Coastal wetlands, they could be flooded as we have melting ice on the globe. Arctic and alpine tundra, talked about that, high elevation mountaintops. Could increase forest and grassland fires due to drier conditions. Could change the places where crops could be grown. This could be a major economic disruption. Could be beneficial in some limited cases, could be harmful. Rapid change is usually harmful. I'll also note that there are some cities like, for example, Nairobi, Kenya, that was built at the elevation where it was built because it was above the mosquito breeding zone. And mosquitoes vector or carry many diseases such as malaria. And as the temperature warms, then the many people that occupy such cities will be subjected to pathogens that they were formerly spared from because of the temperature regime. Here is a photograph of a glacier taken in 1928. Here is the same photograph taken in 2004. So the amount of ice is greatly, greatly diminished. Here you can see both shots at once. This is down in Argentina. More consequences of rapid change. Rise in sea levels approaching 3 feet. That could be devastating because it would threaten coastal estuaries, wetlands, and coral reefs could be threatened. Could disrupt fisheries. It could flood low-lying coastal lands. Something like 2 billion people, a third of the human population, live on coastal plains. It could contaminate coastal aquifers. An aquifer is the underground groundwater, and if that contains fresh water and it's used for drinking. Think of like Florida, and saltwater intrusion into these aquifers makes them useless for supplying humans and with water. Could submerge low-lying islands. There's some countries that are threatened. I already said 1 in 6 humans live there. We could have also cooling in other parts of the world. There are models which predict these changes. Certainly the severity of hurricanes and typhoons could increase as water temperatures increase. This allows the storms to become more powerful. And the whole thing about it is the rapidity, the speed of the change leaves little time to deal with its many effects. Polar ice has been decreasing by about 1% per year since 1979. There it is, 1979. There it is in 2000. There's the two together. And so that's an issue. You understand that there's no underlying land there. That's all just ice that's there in the ocean. In Canada, polar bears are starving because many of the Arctic oceans and the Hudson Bay is ice-free. The major prey of polar bears is seals, and they have to come to breathing holes in the ice for the polar bear to be able to capture them. A polar bear can't swim down a seal out in the open ocean. And so they have to get enough calories during the time that the water is frozen for them to survive. And that hasn't been happening. The melting ice requires more swimming. In 2011, there was a news story that described a radio-collared polar bear that swam for 8 days straight. And it was a female, and it had a cub, but its cub likely drowned. And there's just, it makes the bears fatigued, and then they can be overcome by waves because of storms and causing them to drown. Polar bears are in serious trouble. Here is an aerial photograph of a bunch of walruses sheltering on a beach. The walruses don't swim continuously, but they have to find a place to take refuge, and they used to do this on sea ice, and now when they do it on beaches, it makes them more susceptible to disturbance by bears or by humans. When they do that, they go charging out into the water to escape the predators, and wildlife biologists have been finding many crushed young walruses, and they think it's because of this change in the conditions and causing the young to be trampled as they try to escape. It's pretty sad too. Here is a figure I'm going to just allow you to read through there. I'll just read the major headings. These are some of the negative impacts of global warming. So these are areas that could be affected. Certainly biological diversity, all the different species on the planet, agriculture, water resources, forests, sea level and coastal areas will be affected. Human health can be affected. Human population can be affected, and weather extremes. So these are some of the categories of impact, and you can read through and look at the bulleted points under each heading and really look, and there's some very significant impacts there. Of course, any major event like this allows cartoonists to have a heyday. Shows a couple of sharks looking at a guy over on a small island, and one reading the newspaper says, "Good news, at the current rate of global warming, we should be able to just swim over there and eat him in under 5 years." Yeah, good news. Of course, we've had a lot of naysayers, a lot of debate, and which is unusual because the data shows a very strong trend. But as I said, there's a lot of noise, and of course we have background changes in climate, which can be confusing and difficult to tease out. And so this cartoon kind of speaks to that fact, the fact of anecdotal evidence. If your job depends on you not recognizing global warming, you won't. And someone who doesn't believe in the theory of global warming is someone who might work in air conditioning all day, while actually ranchers in the Southwest are acutely aware of the fact that the climate is changing and warming. So the question comes up, what can we do to reduce global warming? Certainly we want to reduce the amount of greenhouse gases, carbon dioxide that we're putting out. So we want to increase the efficiency of our energy use in every way. That can mean insulating your houses, or carpooling, or riding a bike, buying a car with a 4-cylinder engine, smaller tires, so you can get better mileage. It can make a huge impact on your pocketbook as well. You should use renewable energy sources wherever possible. We should try to tie up as much carbon dioxide as possible in soil vegetation underground and in the deep ocean. They call this carbon sequestering. And the question is, what can you do to reduce CO2 emissions? And here's a list. You can see some of those things. And I know if you don't own your own home, some of these don't necessarily apply. But by thinking about it, certainly the way that you use hot water, because you have to heat water, and water, as you know, has hydrogen bonds and has high specific heat. It takes a lot of energy to heat water. So by using less of it, it can make a difference. And the way we make a difference is one person at a time. So that will conclude this module and this topic of photosynthesis, as well as concluding the material for exam 2, as this is the end of unit 2.